In this video, we'll cover stateful inspection firewalls. Stateful inspection solves the session blindness problem we identified with packet filtering. It's the approach used in most modern business firewalls, and it's the type of firewall you'll encounter at OT-IT boundaries in most current deployments. Understanding what stateful inspection does and what it can't do helps you choose the right tool for the right boundary. A stateful inspection firewall maintains a state table, a record of every active network session. When two devices establish a TCP connection through the firewall, completing that three-way handshake, that session is recorded in the state table with its source IP, destination IP, ports, protocol, and connection status. Every subsequent packet that arrives at the firewall is checked against the state table first. If the packet belongs to a known established session in the table, the sequence numbers match, the source and destination are consistent with the recorded session, then the packet is permitted through without requiring a separate rule match. The session is trusted because it was explicitly established through an authorized initial connection. If an inbound packet arrives that doesn't match any entry in the state table, it claims to be a part of a session that was never established, it's blocked. This closes the attack path that packet filtering left open. An attacker can't simply craft a packet with the right header values and pass through. They'd need to match an entry in the state table, which represents a session that was legitimately initiated. The key difference is context. Packet filtering evaluates each packet in isolation. Stateful inspection evaluates packets in the context of the connection they belong to. Consider a simple example. An OT firewall has a rule that permits TCP from the SCADA server at 10.20.1.10 to the PLC at 10.10.1.50 on port 502. With packet filtering, this rule is evaluated for every packet, inbound and outbound, based on header values alone. An attacker on the OT network segment who crafts a packet appearing to come from 10.20.1.10 on port 502 might pass the rule check. With stateful inspection, the firewall permits the initial connection from the SCADA server to the PLC because it matches the rule, records that session in the state table, and then permits all subsequent packets belonging to that session based on the state table entry. A packet that claims to be part of a session that was never initiated by the SCADA server doesn't match any state table entry, and it will get blocked regardless of what its header says. For return traffic, stateful inspection also eliminates the need to write explicit rules permitting return packets. With packet filtering, you would need to write a rule allowing traffic from the PLC back to the SCADA server, which is the response. With stateful inspection, the return traffic is automatically permitted because it matches the established session within the state table. Stateful inspection understands TCP and UDP sessions, but it doesn't inspect the content of those sessions. It knows that a session from the SCADA server to the PLC on port 502 has been established. It doesn't know what Modbus commands are being sent within that session, whether those commands are read requests or write requests, and whether the write values are within expected ranges. From the stateful firewall's perspective, all traffic within the established session is equally permitted. This creates a blind spot for two scenarios. First, an application that communicates on an unexpected port, or malicious traffic encapsulated inside a legitimate protocol. The firewall permits traffic on port 502 and assumes it's Modbus. If something else is using that port, the firewall doesn't catch it. Second, and more specific to OT, an attacker who has legitimate network access, perhaps through stolen credentials or through compromising a device that's already permitted through the firewall, can send arbitrary Modbus commands to a PLC, and the stateful firewall won't distinguish those from legitimate SCADA polling. The session is permitted, the payload is invisible to the firewall. Next generation firewalls covered in the next video will address this by looking inside the packet payload. One practical consideration when deploying stateful inspection in OT environments: maintaining the state table consumes memory and processing on the firewall. For high traffic environments, this is a hardware sizing question. For most OT environments, which have relatively modest traffic volumes compared to enterprise IT, standard stateful firewall hardware is more than sufficient. More relevant to OT is the latency question. Stateful inspection adds slightly more processing time per packet than simple packet filtering because the state table lookup is required. In most OT applications, this latency is microseconds to low milliseconds, negligible for SCADA polling, historian collection, and similar applications. In very tight real-time control applications where sub-millisecond timing is critical, the network architecture should account for this, typically by keeping those critical control paths within a single VLAN segment rather than routing through a firewall. Stateful inspection firewalls should be placed at zone boundaries where traffic volumes are moderate and where the improved security over packet filtering is worth the slightly higher cost and complexity. They're the standard choice for OT, IT, DMZ boundaries, remote access entry points, and inter-VLAN boundaries in security mature OT deployments. In the next video, we'll cover next generation firewalls, which add deep packet inspection and intrusion prevention capabilities.